Okay, example 5. You're looking at pasta sauce. You have 5 different vegetables to choose from on the table, and you haven't decided how many different to put in, so you're just gonna kind of do it at random. Um, and how many you can choose anywhere from 2 to 5. What's the probability that you choose carrots in the sausage or sauce, so that like they're one of the 5? And so this is kind of like the pizza toppings question. N of S actually has 4 cases, 5 choose 2 through 5 choose 5. Um, and if you're looking at this as Pascal's triangle, you could calculate these separately, but this is the 5th row of Pascal's triangle. It would add up to 2 to the 5, but it's missing 5 choose 1 and 5 choose 0. So if you subtract those off, then really you've got 2 to the 5 minus 5 choose 1 and 5 choose 0, which is 26. So that's N of S. N of A, you actually have to have carrots. I think the last time we did this question, we did it with the indirect method. So here, like, we're going to look at it doing the direct method, having carrots and others. So like out of the carrots, we're going to choose carrots, but then out of the 4 others, we're going to choose 1. So that would satisfy the 2 case, or if you had 2 vegetables. If you had 3 vegetables, out of the 1 carrot, we're going to choose 1, and then out of the 4 others, we're going to choose 2. And so these are each cases kind of like the cards question where like you're choosing carrots for sure, 1 choose 1, and then you've broken up. The others are 4. So we can choose anywhere from 4 choose 1 to 4 choose 4. And really the 1 choose 1 doesn't really matter. So it's just like there's only one way to do that. So it doesn't do anything when you multiply it. So really what you have is 4 choose 1 to 4 choose 4, which is the 4th row of Pascal's triangle, which is actually 2 to the 4 minus 1, which is 4 choose 0. But you can add up all those numbers, 4, 6, 4, 1, and you get 15. And the probability is 15 out of 26. So 58% chance of using carrots. 5 girls and 6 boys are planning to meet for dinner. What's the probability that the first 3 to arrive are 2 boys, then 1 girl? And so this is a slot method question. You've got 3 slots, 11, 10, 9. We don't care about the rest because like we just care about the first 3. But if you wanted to do all 11 people, you would do like 11 factorial. N of A, I would set up the slot method and just say we want the first 2 to be boys. So 6 times 5, and the next to be girls, so 5 girls. And so there's 150 ways to do that, and the probability is 15%. Example 7, if you're dealt 5 cards, what is the probability that your hand contains a straight? This is a pretty complex question. N of S, we realize, is 52 choose 5. The 52 cards, you could choose 5 of them. But if you want it to be a straight, so like ace to 5, 10 to ace, anything, just 5 cards in a row, it could start at ace to 5, 2 to 6, 3 to 7, 4 to 8, all the way up to 10 to ace. 10 to ace actually counts as a straight as well. 10, jack, queen, king, ace. And so what we do is we look at the first case. So if it's ace to 5. So if it's, we kind of have like slot method, but we're just saying like out of the 4 aces, we're going to choose 1. Out of the 4 twos, we're going to choose 1. Out of the 4 threes, we're going to choose 1. So we've got this 4 times 4 times 4 times 4 times 4 working for us. The next case would be 2 to 6, would be the same. These will all be the same, all the way up to 10 to ace. And so really, there's this 4 choose 1 times 4 choose 1, all the way up to like 5 of those, times 10 different cases. So we get 4 choose 4 to the 5 times 10. That's 10,240. And so the probability is 0.39%. And our last example, password's 5 letters long. You know that it starts with A. You can only use each letter once. What is the probability that the password has at least one other vowel? So N of S would be your 5 slots. It starts with A, so it's really only 4 slots, but we'll just put it down for now. Because we can only have 25 letters next. 24, 23, 22. So that's 25P4. And then N of A, we're going to think of instead a prime where we're not using any other vowels. And so we've got 5 slots. We've got to use A. but we can't use any other vowels, so there's only 21 choices, 20, 19, and 18. And that's 143,000. If we subtract those, we get at least one other vowel, and then divide, we get the probability. And there's some practice questions.